Welcome back. In section 5.2, we look at one-to-one functions and inverse functions. Okay, so the one-to-one function, that should be mostly a review, but I want to make sure to do a quick little review of that. So the function is 1-1 if each input corresponds to exactly one output. And so up to here, all we've done is make sure that it is actually a function. So we basically have to go both ways. We have to make sure every input has a unique output and every output also corresponds to a unique input. We'll just do a couple quick finite examples with that. So if I have elements A, B, and C in the domain and range 0, 1, and 2, this would qualify to be called a one-to-one function. Every element of the domain corresponds to exactly one element of the range, and each element of the range can be traced back to only one element of the domain. So if I add one more element to my domain and I map A to, let's map that to a 1, B will map to a 2, C will still map to 0, and D also maps to 1. This is still a function. This first one was a function and one-to-one. This is still a function, but not one-to-one. So 1 corresponds to both A and D. So we add one output value corresponding to two input values. That's enough to prove that it's not one-to-one. If my domain has, let's say, elements 0, 1, and 2, range has A, B, C, and D, and I map the 0 to a C, 1 to both A and D, and 2 to the B. This one is not a function. If it's not a function, it can't be a special kind of function. So it doesn't matter on here that every output value had a unique input value. A can be traced back to only one place. Similarly for B, C, and D. If it's not a function at all, it's not going to be a special kind of function. So some more infinite examples would be something like y equals x squared minus 4. first of all, this is a function. Take a value and square it, you only get one number. Subtract 4 from that, you still only get one number. Every input has its own output. But let's say that y is 0. Then we have 0 is x squared minus 4. 4 is x squared, so x is plus or minus 2. So we have one output corresponding to two inputs, not 1-to-1. Y equals square root of x, however, our domain here would be the positive real numbers as well as 0, so non-negative real numbers. Our range, also non-negative real numbers, and we don't have any repeats. Every time we plug in an x value, we take the square root. There's only one number we get when we take that square root. We don't have a plus or minus hanging around out in front of here. So this is a function, and any given y value can be traced to exactly one x value. So this is also 1-to-1. Whereas back in chapter 1 we got to play around with circles. This is not a function at all. If it's not a function, I don't even have to bother checking to see if it's a special kind of function. So if a function is 1-to-1, then there exists an inverse function. Backwards capital E, there exists. Sort of a common math shorthand that you'll see more and more as you start getting into more advanced courses. So if f is 1-to-1, then there exists f inverse such that upside down capital A for all xy on function f, yx is on f inverse. So in other words, whatever f did to our input, plug that into f inverse, we're back where we started. So whatever one of them does to something, the other one will undo it. So if I want to verify that these two are inverses of one another, there's two things I'll show. I have to show that f of g of x is x, and that g of f of x is also x. So I'll start with f of g of x. So keep the framework of f, so a fifth root of something plus 1, and the something we're going to plug in is x to the fifth minus 1. So f of g of x is the fifth root of x to the fifth, so the minus 1 plus 1 knock each other out. So f of g of x is x. So we're halfway there. If we came up with something else, we can stop the proof there. They would not be inverses at that point. If we make it through round 1, we go to round 2. So we find g of f of x. So remember, there's kind of two common notations for composition. So that says keep the framework for g, something to the fifth and a minus 1, and plug in this case, f being fifth root of x plus 1. Fifth root and fifth power cancel each other out, so g of f of x is now x plus 1 minus 1, so g of f of x is also x. So now we've shown that they are inverses. So not only do we occasionally work on finding inverses, or showing that two things are inverses of one another, we do also work on finding inverses. We used f and g already. I'll call this guy h. So we'll do a 2x minus 7 over 3x plus 5. So I start by switching out a function notation temporarily, and we'll put it back at the end of the problem. So y is 2x minus 7 over the quantity 3x plus 5. So back to this idea that x and y are trading roles on inverse functions. So then on my inverse, we would have x is equal to 2y minus 7 over 3y plus 5. And then we're looking to solve for y. So first we'll clear the fraction, multiply both sides by 3y plus 5. So I have x by 3y plus 5. It's worth 2y minus 7. We'll do a little simplifying on that left-hand side. So I have 3xy plus 5x is 2y minus 7. Then we'll get all of our y's onto one side, anything without a y onto the other side. So these two guys had the y's. So I have 3x minus 2. Each of those were multiplied by y is worth negative 5x minus 7. So y is negative 5x minus 7 all over 3x minus 2. So then I just go back to function notation. So this will be h inverse of x. Negative 5x minus 7 upstairs, 3x minus 2 downstairs. Now if you graph a function and its inverse, they're always going to be symmetric about the line y equals x, because x and y are sort of trading spots. So get a little more room to work. So we're symmetric about the identity function. So if 0, 1 is on my original, that means 1, 0 is on my inverse. And notice they are equidistant from that line. If, let's say, negative 2, positive 1 is on my original, then on the inverse, so if this guy, again, was negative 2, positive 1, then at 1, negative 2, I would have an equivalent point. And again, this sort of mirror image, equidistant from the identity function. Okay, so that gives us enough ammo to sort of work our way through section 5.2. So the problems I would recommend, let's see, try out 25 to 81 on the odds. If you have questions, please get in touch. Otherwise, I will see you next time. Stay safe out there.